innovative bakery technology from Werner and Pfleiderer, the continuous vacuum cooling system. The vacuum cooling of bakery products under outer space conditions. How does it work? Under normal conditions, 1000 millibar, water boils at exactly 100 degrees Celsius. If the atmospheric pressure drops, so does the boiling point. At the summit of the Matterhorn at 605 millibar, water boils at just 87 degrees Celsius. On Mount Everest, at as little as 72 degrees. On our neighboring planet Mars, the atmospheric pressure is only 10 millibar. Water here would boil at a mere 7 degrees Celsius. Let's look at an experiment. The beaker contains water at 100 degrees Celsius. The air pressure is 1000 millibar. When we reduce the air pressure, the water begins to boil and the temperature drops until a new pressure balance is reached between the water and the environment. If we reduce the pressure again, the process is repeated. Under outer space conditions, the water would freeze. One practical application of this basic thermodynamic principle is vacuum cooling of bakery products. The stationary vacuum chamber from Werner and Pfleiderer has already proved a success. Werner and Pfleiderer now offers vacuum cooling for continuous processes as well, for high capacities with linear throughput. At predetermined intervals, the transport system delivers a batch of hot bakery products into the vacuum chamber. The entry port is closed, the pumps are switched on, and the internal pressure drops. Immediately, the hot, moist products begin to produce steam, and their temperature begins to drop. The vacuum pump extracts air and water vapor from the chamber. The steam is eliminated by the condenser. A rehydration process at the end of the cooling period partially compensates for the water lost from the products. The time needed to reach the required final temperature is only about 3 to 6 minutes, depending on the product. The cooled products can now be cut and packed, and the vacuum chamber is ready for the next batch. What actually happens inside the product during vacuum cooling? As soon as the air pressure drops, water vapor is released and the core temperature of the product sinks. The flow of steam through the outer layers cools the crust rapidly. And so the temperatures of the crumb and the crust converge during the vacuum cooling process. In this way, the product is cooled from inside to outside, much more evenly and quickly than by conventional cooling techniques. After cooling, the rehydration process almost balances out the water loss, so that the products have the desired moisture content for optimal quality and freshness. With appropriate transport systems, the Werner and Pfleiderer continuous vacuum chamber can be integrated into practically any baking process, professionally and individually tailored to meet the customer's requirements. Here the vacuum system is working with a tunnel oven, whose permanently running mesh belt delivers a steady supply of freshly baked products. First, the hot products are collected on an independent holding system or buffer. A shuttle converts this continuous flow into the batch-wise loading necessary for the vacuum chamber. It takes the products from the buffer, brings them to the vacuum chamber, and then returns to the waiting position. In the vacuum chamber, the products are cooled to the required temperature and moisture content for optimal quality and freshness. The cooled products are then passed on to the continuously running conveyor belt. At the same time, the first shuttle brings the next batch from the buffer and reloads the vacuum chamber. In this way, the batch-wise discontinuous vacuum cooling process is seamlessly integrated with the continuous baking process in the tunnel oven, with perfect results. In this system example, the continuous vacuum chamber is working with the Werner and Fleiderer Megadoor oven. The Megadoor produces a batch of products from each of its decks at regular intervals. The stationary loader at the oven exit transports the batch directly onto one of the vacuum chamber decks. While the cooling process begins, the loader delivers products to each of the remaining vacuum chambers. Meanwhile, the cooling in the first chamber is completed and the products are removed by the unloader at the exit and transported away. The Megadoor oven's continuous baking process consists of synchronously coordinated process cycles. In summary, the advantages of the continuous vacuum chamber are rapid cooling, even with large quantities of products, in a maximum of 6 minutes. The compact and adaptable design takes up little space. It consumes less energy than existing systems. Excellent product quality thanks to individual process control and rehydration. Optimal hygiene because there's no unnecessary external contact. Maximum shelf life when products are carefully packed directly after cooling. Innovative bakery technology from Werner and Fleiderer, the continuous vacuum cooling system.